Here we have a Python application for which we're going to build a crypto bill of materials. To be able to build the CBOM, we need to set up an actions workflow in the repository to do this. The first part of the actions workflow will identify all of the different languages and all of the different packages being used by those languages. The second part will actually kick off the analysis both for the code in the repository and for all the dependent packages. And the last part will actually build the results. Here we can see what the manifest file for this particular Python application looks like. And here you can see GitHub has already been able to analyze this and tell us what the dependency tree looks like. So now let's go ahead and kick off our crypto bill of materials run. So I'll kick off running the workflow. And if we drill into this, if we give this a moment here, what we'll see is the actions workflow will go and identify all of the dependencies, and then it will kick off analysis runs for each of those dependencies. So in just a moment, we should see this pop up here. So you can see here, it's now starting to populate all of the separate runs for each of the packages that we have. Very soon, we should start to see results for packages where we already have cached information about the CBOM for that particular package. So if we give this a second here, we can now see for IDNA, we have some results back. And if we drill down into the log output here, you can see that as we scroll down and have a look, you can see here the Sarif results have been collected already, and they've been downloaded directly from the repository where we have it cached. And this is the repository where that information exists. So this repository is now open sourced, and this contains all of the CBOM information for all of these particular packages that we have in here. And you can see here we've also captured the commit SHA as well, so you can identify uniquely to which version of that package it's come from. Next, we should start to see some results from packages where we don't have cached information. So if you have a look here, we can see the CBOM action has come back. And for this particular package, we already have a CodeQL database that's been built and cached, and GitHub already does this for many open source packages. And here you can see we've downloaded that database and we've run the queries that are looking for PQC type algorithms inside there. So now that we have this information, we can take this and put it alongside the cached information that we collected previously. Now, for these repositories where we've had to go and do this initial work, we will actually automatically create an issue inside our repository where we're capturing all of this cached CBOM information. And this will be treated as a backlog activity that someone in GitHub will run in the future and then go and extend that database for future use. And so now that we're done here, if we scroll to the bottom, you can see here we now have the CBOM results for this particular Python application that we've run. That was a quick demonstration of the CBOM capability for GitHub Advanced Security.